Welcome to Nana's Planet, my dear children. Children, in the previous session we discussed about pulley and an inclined plane. And in today's session we are going to continue this lesson of force, work and energy. And we are going to study about wheel and axle, wedge and screw. So let us start with this session. Yes, wheel and axle. Children, wheel and axle is a simple machine. It consists of a wheel which is rigidly attached to a rod called as axle. So, wheel and axle both are attached together in many objects and many things, and then they are used in various ways. So we can basically say that wheel and axle is a simple machine which consists of a wheel which is rigidly attached to a rod called as axle. So when one rotates the wheel, the axle also rotates, right? And if one rotates the axle, wheel rotates, right? So remember that the wheel and axle consists of a hand wheel. That means a disc or a lever arm with a handle which turns an axle around which a cord is wound. So a heavy weight attached to the cord can be lifted more easily by using wheel and axle. For example, you can see here, this is the ancient type of train, and here you can see that this is a wheel and this is the axle, right? So you can see that when one rotates the wheel, the axle also rotates with it, right? So this simple machine consists of a wheel and axle, both. So what are the examples in which this wheel and axle are used? Let us see. Yes, the crank. The crank is used to raise a bucket of water from a well. You can see in the picture, right? This is a picture of a crank. So crank is basically used to raise a bucket of water from a well. So we can say that wheel and axle is such type of simple machine which actually makes our work easier while lifting a bucket of water from the well. So we can say that this heavy object can be lifted up if it is attached to the cord, and it can be lifted more easily because of the mechanical advantage. Mechanical advantage means every time we turn the wheel once, our force will be multiplied 4 times. It depends upon its radius, and the mechanical advantage is actually the ratio of the radius of the wheel to the radius of its axle. So there are many examples of wheel and axles, like bicycles, Ferris wheels, gears, wrenches, door knobs and steering wheels. Here you can see the picture of a wheel. This is a door knob. This is a scooter, right? And the wheel is attached to it. This is a picture of a woman or a worker, lady is actually pushing on the wagon, and here this wheel is attached to it and an axle is attached to it. This here you can see that this is an axle and this is a wheel. Even the wheel and axle are very important in the roller skates. It plays a very important role in this thing also, right? So basically we can say that in ancient time, wheels do not exist in nature and no animals use them except people. Even people didn't use wheels until the early Bronze Age, that is around 3500 BC, before Christ. But much later than the other machines, simple machines were already invented, like the lever and inclined plane. But we can say, and it is very amazing, You will be very amazed to know that the earliest evidence for people using wheels comes from the modern Iraq, that is about 4000 BC, just about the time when people first began to live in cities. The earliest wheels were probably not the wagon wheels but pottery wheels. And soon after that, maybe around 3700 BC, people in the Central Asia were making wagon wheels, right? So there are some examples also in which people started making wagon wheels. Here you can see that an axle is attached to the wheel and wheel is moving, and because of this it is able to move such a heavy object like a vehicle, two-wheeler. Why we call it as two-wheeler? Because it has two wheels, right? Why we call a vehicle as four-wheeler? Why we call a car as four-wheeler? Because it has four wheels, right? So basically we divide into many categories depending upon how much wheels are attached to it. Here you can see this example of a cart which have four wheels. Here you can see that wheel is also used as a steering for driving a heavy object like a steamer or a ship, or even steering wheels are used in cars. This is a wagon wheel. This is a cart which is pulled by animals. But wheel and axle makes the work easier for the animals to pull such a cart. Even in the ancient times, this is the ancient time telephone. Even the music player, wheels were used, they were attached. Here you can see one example of a rotary dial telephone, right? In that also wheels were used. Yes, wheels were also used in the riverboat. This is a picture of a stern wheeler of riverboat. This is a picture of the spinning wheels which help in navigation, and that is why they are termed as navigation spinning wheels, right? And this is the barbecue. In that also wheel and axle plays a very important role. In bicycles it is used, and in carrying any type of load, right? So it is used in many ways and in many places, in many objects. Wheels help people to do work in two ways. First, like levers or inclined planes, wheels allow us to do something easy for a longer time instead of doing something hard for a shorter time. So if we turn a large wheel which is fixed to an axle, the axle will also turn. We can turn the large wheel easily, but it takes a lot of turning to go all the way around. For example, a train, the axle will go around a much shorter distance but with much force. So if we can use a wheel to create a mechanical advantage, that means we can turn something heavy by spinning a large wheel attached to an axle that is attached to a heavy thing, right? And that is how a pencil sharpener also works. Or we can do it in the other way around. We can use a lot of force to turn the axle, and that will spin the wheels really fast. That's what cars do, right? Also wheels on a wagon only touch the ground at one spot at a time, keeping the rest of the wagon off the ground, right? So this makes less friction, so that wagon is easier to move than if we were pulling it along like a sled. Now here you can see some more examples. This is a picture of a very ancient type of music player for the passionate music lovers who are passionate for music, right? So this is a type of wheel used, or we can rather say that this is a type of CD, right? Here is a windmill, which we studied in the previous session, that windmill is used to generate electricity, and that also wheels are used, wheel and axle is used. In table fan also wheels are used, right? So in many things, wheels play an important role. Wheels are the most important part of pottery wheels, wagons in cars, but also of wheelbarrows. also of spinning wheels, water wheels and pulleys. So these are all examples of wheel and axle. Pencil sharpener, casters, doorknobs, rolling pin, rotary dial telephone, bicycle, fan, windmill, roller skates, record player, wagon, etc. Right? So this is actually termed as simple machine, which makes our work very easier by using such type of tools. Okay? So now let us study about wedge. Yes. So what is meant by wedge, children? A wedge consists of two inclined planes that meet at a sharp edge. Wedges are often used to cut or split objects. As you can see here in the picture, this is a wedge, right? And you can assume or imagine the shape of this wedge. If its shape is like this, that means it is often used to cut or split the objects. So like screws, wedges are really a kind of an inclined plane, but they are so useful that people give them their own category. A wedge is consisting of two inclined planes back to back against each other. Wedges evolved on their own long before the people. Like we can say that people have been using wedges in Africa since the earliest Stone Age, that is about 2.6 million years ago. And these early wedges were stone hand axes, and their sharp edges let people cut a hunk of meat off a gazelle to eat, or cut branches for firewood. So probably people also used wooden wedges to split bigger pieces of wood into smaller pieces. So let us see some of the example and learn more about wedge. Yes, this is a picture of a chisel. This is a picture of an iron wedge, or we can also say a sledgehammer. Then this is a picture of a knife, which looks like a wedge. This is hacksaw blade, right? So all these are examples of wedge. Even there are some more examples like rolling pins, or simply the pins. The head of the nail or a pin looks like a wedge. Even a sledge is a type of wedge. Even you can see in this picture a doctor is holding a syringe. A syringe also consists of, an injection also consists of a needle. A syringe also consists of a needle, and the tip of the needle is a type of wedge. Even you can see here, sharp teeth are a kind of wedge that cuts through meat and vegetables when fish or crocodiles eat something. This is one such picture of a shark is having sharp teeth. So this is also a wedge. You can see here, right? I'm pointing it out for you. This is a type of wedge. Their tooth, right? So these sharp teeth are a kind of wedge that cuts through meat when fish or shark or crocodiles eat something. So basically the mechanical advantage we get from a wedge depends on how thick it is. A thick short wedge will split things apart faster, but we will have to push down on it with more force. For example, hitting an object with a hammer. A thin long wedge will be easier to drive in, but it will take longer to split something, right? For example, you can see here, this is the tip of the needle. The tip of the needle looks like a wedge, right? Today we have many different uses for wedges. Like a plow, it is also a kind of wedge. A knife, it is also a kind of wedge. Even a fork, which is made up of 4 little wedges. Even the razors and scissors, they are also a kind of wedges. So are door stops. A nail is a kind of wedge, and so is the pointed nose of an airplane that helps it cut through the air more efficiently. So we can say that a wedge is also a simple machine which is used to separate two objects or portion of the objects through the application of force. A wedge is made up of 2 inclined planes, and these planes meet and form a sharp edge, and this edge can split things apart. wedges are used as either separating or holding the devices. So there are basically two major differences between inclined planes and wedges. First, in use, an inclined plane remains stationary while the wedge moves. Second difference between an inclined plane and wedge is that the effort or the force which is applied parallel to the slope of an inclined plane, means the force is applied parallel to the slope of an inclined plane, while in wedge the force is applied to the vertical edge, that means the height of the wedge. So force multiplication varies inversely with the size of the wedge angle, whether it is a sharp edge or any kind of edge. So wedges are basically used as either separating or holding devices. A wedge can be either composed of one or two inclined planes. A double wedge can be thought of as two inclined planes joined together with their sloping surfaces outward. So floor nail, back wedge, pins, iron wedge, also called a sledgehammer, then shark tooth or a crocodile tooth, then chisels, car tire wedge, or old knitting needles, like here you can see in this picture. These are the knitting needles. So these all are the examples of wedge, right? So that was all about wedge. Now we will learn about the last but not the least simple machine known as screw. Right, so what is meant by a screw? What is actually a screw? Yes, a screw is an inclined plane which is coiled into a spiral form, as you can see here in this picture. Now a simple demonstration will show us that how a screw is actually an inclined plane. So for this demonstration we need to have pencil, paper or colored felt tip marker or scissor, right? So basically we can draw it over here, and I'll show you that this is an inclined plane, right? Here is a pencil. Let me draw it for you. Just imagine that this is a pencil. Okay, so this is a pencil and this is an inclined plane. Look, like we can use a paper, and we can take a paper and we can cut a right triangle from the paper. So if we will cut the right triangle from the paper, we will get such a type of an inclined plane, 0.3 inches. Then we can use the felt tip marker to color the longest edge of the triangle, and then position the shortest side, that means the 5 inches of the triangle, along the side of the pencil, and then evenly wrap the paper around the pencil by rolling the pencil. So when you will roll the pencil, what will happen when we actually roll the pencil? What happens? It will look something like this. Like this is a paper which has been rolled, and this is a pencil over here which is wrapped by the paper, right? So by doing this simple type of demonstration, we will get this type of shape. So a screw is basically a specialized application of the wedge on an inclined plane. Means it contains a wedge which is wound around an interior cylinder or shaft that either fits into a corresponding plane in a nut, or it forms a corresponding plane in the wood or metal as it is inserted, right? So the critical applications of screws and bolts specify a torque that must be applied when tightening any object, right? So basically we can say that a screw is an inclined plane which is coiled into a spiral form. For example, the screw cap of a bottle, that is an example of a screw. Even a screwdriver, a screw jack, which is used for lifting a vehicle. The screwdriver, this is the lower side of a bulb which acts as a screw. This is the cap, the bottle cap, which acts as a screw. This is the drilling machine. This also acts as a screw. Even the bulb which we saw right now, a person is actually fitting a bulb. So while fitting also, we can say that the lower part of the bulb acts like a screw that it can fit into it, and we can switch on the bulb. And this is a screwdriver which fits on or fixes the screw in, right? So all these are examples of a screw. Brace and bits, screw lid jar, meat grinder, drills, door lock, machine screws. All these are an example of a screw, right? So that is all about a screw, which is a type of an inclined plane coiled into a spiral form, right? So I hope you enjoyed today's session and learned about all the simple machines, from lever to wheel and axle to pulley, screw, wedge and inclined plane. So basically we studied about the simple machines, but have you ever gave a thought, children, that why we need to study about simple machines? Why we studied about simple machines? Yes, let us discuss about it. I'll just tell you, and you will have to listen carefully, that people use machines to help them do work more easily, because a machine uses energy to do work, and machines can change energy from one form to another form. Machines make our work easier by changing the strength or direction of a force, and that is why they can be simple or complex. Simple machines have only a few parts. Compound or complex machines are made up of two or more simple machines. Some simple machines are levers, pulleys, inclined planes and wheel and axles, which we discussed. Levers are used to lift, move or pry the things by changing the strength and direction of a force. Inclined planes are used to move things to a higher place by changing the strength of a force. Inclined planes are used to split things by changing the direction of the force. Same way as wheel and axle are the machines, simple machines, which are used to move and turn things by changing the direction and strength of a force. So basically we can say that machines are very useful to us. Even some work is wasted by machines because of friction. Friction can be lessened by using a lubricant. Efficient machines do not waste much work or energy. That is why it is sensible to use efficient machines. So basically we use wheel and axle, pulley, screw to make our work easier, right? So that was all about the simple machines. So we will meet in the next session with a new lesson. Till then, keep learning and keep enjoying. Thank you, children. Bye-bye.